The mucus layer is extremely important for the healthy gut, especially because it causes a separation between the microbes and microbial toxins that are naturally present in our gut. And then, because of this separation, the microbial toxins cannot trigger inflammation, cannot trigger the immune defense. When the mucus layer becomes compromised, and we see that in cases of inflammatory bowel disease, which is also called IBD, what happens is that the bacteria and the toxins come closer to the gut tissues.
What we knew from a polymer chemistry perspective was that as you go to very long chain-like polymers, that the properties that you think of being typical of polymers can really be accentuated as you go to really high chain lengths. And it turns out that Mother Nature figured this out a long time ago and has engineered mucins, which are naturally occurring polymers, to also be very high molecular weights. So once we realized that we could make polymers, synthetic ones, that were on the same size scale as these natural ones, we thought this was a pretty good target to go after. Instead of making polymers that look just like mucins on a molecular scale, we decided to make polymers that behave like them on a macroscopic scale. We call these polymers SLIPs, and this stands for shear labile interaction polymers. It also is a nice play on the word slippery because they do create surfaces that are quite slippery, which is important for a lot of these. The idea that these polymers are shear labile, it means that they can interact with one another, but when you shear them, they can break those interactions. And then when you remove that force, then they can reform those interactions with new partners that are now beside. It's important that these mucins coat the inner lining of your intestines as a way to help facilitate transport.
Up to now, the only way of treating IBD is by reducing the inflammatory response. So we are basically asking the immune system to calm down. We can change the field by, instead of suppressing the immunological system, preventing the inflammatory response to happen in the first place. That's the whole idea. And by doing this, I believe we can reduce the dependency of immunosuppressive drugs, and hopefully we can also reduce symptoms and keep a remission, which is the time that people with IBD remain without disease for a longer time, for a longer period of time. But at this moment, my understanding is that our goal should be moved to phase 1 human trials. We want to test this on humans, so the first phase will be related to safety and dosage. It requires FDA approval, but that's our goal for 2026. We want to move to human trials.